need to record this for the sake of a couple of people that cannot be here. So anyway, I'm going to go ahead and do a quick record. So when we dealt with inverses, we went through a couple of pieces, and this was a bummer because everybody I think we had 7 people left in the room. Almost everybody was gone. So this is, I feel, a lot less confident that we're in good shape on. And you haven't done this at all in Algebra 2. So the story of inverses. See if anybody remembers what the first rule of inverses that you do. What happens to x and y? You switch. So x and y switch. Now, again, what that does for us is x normally speaks to domain, doesn't it? And y speaks to range. So when you find the inverse, the domain and the range switch places. So you'll hear me make reference to this. I hate finding range. It's the hardest thing to find because you're actually not saying what question I could ask. It's like, what are all the possible answers I could get to every infinite number of questions? That's hard. But the cool thing here is I don't have to. Because if I find the domain of the original, I automatically know the range of my inverse. And if I know the domain of my inverse, I automatically have the range of the original function. So that makes it fast. So that's number 1. My next rule is after I swap x and y, what's the next thing we always try to do if we can? We try to isolate y. We just try to get it redone in that way. And number 3, which in a sense is actually supposed to be number 1, but this is not how most students do it. Most students put their head down and they go, oh, that's when you swap x and y and you go for it. But really what you're supposed to do is check to see if the function is 1-to-1. And this is a really, really subtle piece that I've got to say I will hammer you on it over and over this year. And I guarantee you almost every single one of you, I will write a nasty note to you on a test that you forgot to check if your function was 1-to-1. It happens every year without fail. See, 1-to-1, what does a function have to pass? What's that special rule that you learned long ago? The vertical line test. See, the vertical line test says if I give you an input, there has to be a well-defined output. But the problem is that's not enough. See, if you're going to flip it around and you're going to make the domain and range change, that soda machine that we talked about before where there was 3 different buttons that could give you water, I can't do an inverse. Because that means water, where did it come from? It came from 3 different buttons. 1-to-1 says every question has 1 answer, but every answer, there's only 1 legitimate question that you could ask to get that. It has to be a machine where every button is different and all of the outcomes are different. So that means it has to pass the vertical line test and the horizontal line test. Okay, we want to pass both the vertical line test as well as the horizontal line test. So in order to make this just go fast, I'm going to jump to the question that I didn't get to last time. So imagine we have f of x is this function right here. This is a naughty question because it is not 1-to-1. What is this the graph of? It's a parabola. Do you follow why it is a problem? What does a parabola look like? Does it actually pass the horizontal line test where a horizontal would only hit at 1 place? This says, hey, then you can't do that. You're not allowed to do that. So I'm going to show you what I do. Don't do this yet. I'll show you what to do in a second. But let's draw a picture of it. I know that this particular graph has a vertex at 3, 4. Are you guys comfortable with saying that that has a vertex at 3, 4? I think you did all of that back in your Algebra 2 days. And it looks kind of like this. Again, don't do this yet. Is this 1-to-1? Can you see what it fails miserably? The horizontal line test. But the thing is I'm going to be insistent. I really, 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 really want to do it anyway. So I just do this. Does it now pass the horizontal line test? What did I throw away? I threw away the left half of the graph because that was the place where it was a problem. Is it now going to pass both tests? But I had to modify it. So watch what happened. So I just changed my problem to a domain above 3 and a range above 4. You guys following that? Now, this was not because it naturally needed that. It was because of the question that I asked. It's kind of like saying, I made this reference to the other class. It's like, is there anything wrong with wearing basketball shorts? Probably not to a job interview. See, this is a slightly more significant story. Actually, I used like grandma's funeral in that one because that'd be horribly disrespectful, right? So, you know, it's not that there's a problem with values below 3, but it's a more formal situation if they're saying go find the inverse. So I need to make it 1-to-1. So the rule is you throw away as little as you can. So sometimes if there's a problem where you just had to throw away a little bit, then throw away a little bit. Did I have to throw a little bit away here? I threw away half the graph. Literally half the graph made this thing bad. So anyway, let's figure out what this inverse is. But before we do, let's talk about what happened after. You see that 2? It got multiplied by 2, didn't it? So what's the inverse going to have in it? It's going to have a divide by 2. This thing has a -3 in it somewhere. So what's the inverse going to have? A +3. This thing has a square in it. What's the inverse going to have? A square root. And this one has a +4. So somehow all of this is going to have perfect like answers to all the questions and go backwards and be argumentative the whole way and unravel itself perfectly. So just for fun, could somebody give me a number not too big above 3? What's that? 4. That's fine. That was pretty easy. Let's plug in 4. What is 4 minus 3? Squared is 1 times 2 is 2 plus 4 is 6. Did I do that right? Okay, so if I have done this right, what should happen on my inverse? I should get 6, 4. Okay, so here we go. Let's swap x and y. So step 1, I did this. I swapped x and y. Now, this is a little uncomfortable for people, but this is not called evaluating. It's not, because evaluating means I have answers for x and y. I'm just plugging it in. When you do this, you actually do PEMDAS in reverse. So this is going to feel a little bit awkward to some of you because you religiously use PEMDAS, and we still do. But let's get rid of the add and subtract first. So where's the add and subtract that I'm looking at? Yeah, let's get rid of it, x minus 4. So we got rid of the add and subtract. Now what should we get rid of? The 2. Let's get rid of that multiply that's sitting in front. Where am I after? Now that I'm looking back through the whole list, what would be the next thing to go? How do I get rid of the square? I take a square root. Okay, what's left in my whole story? Isn't it the parentheses? How am I going to get rid of that parentheses right now? Don't I need to add 3 to both sides to get y 100% by itself? I do. And so if I add that 3 to both sides, and by the way, this is something I'm picky about, the name of my original function was f, and now that I have this by itself, we are going to go back and remind ourselves where it came from. That is called f inverse. Now let's try the number that somebody gave me. 4 gave me 6. So guys, what happens if I plug in 6 right now? What's 6 minus 4? 2 over 2 is 1. Square root of 1 is 1, plus 3 is 4. So now when I plugged in 6, I got the answer 4. Now why did I have to cut this off again? Let me remind you. What did we have to do? Why did we have to do that? Because the problem was not 1-to-1 as it started. So I had to do something to make it better. Now, I want you to follow the same logic that I just used. So your turn is to do g of x. You're going to do 3 parentheses x plus 2 quantity squared minus 11. So guys, where's the vertex? -2, -11. It's some parabola down here, right? Certainly not 1-to-1 yet. See if you guys can do it. See if you can go through the process to make that function actually invertible and find its inverse. Okay, Maisie, do you know how to change the domain to make it work? Because it's not 1-to-1 right now. What do I want to do? Let's take away a side. Which side should we take away, the left or the right? It's kind of a funny question, isn't it? Couldn't we take away either side? Which side would be the easiest side to take away? The left side. We always take away the left side because we want to leave things positive if we can. So I'm just going to go bigger than or equal to -2, which is, okay, cool. So far, so good? All right. So that's good. Who can tell me the first step when we swap x and y? Who can express that well? Thanks, Jacob. What is it? Good. 5 plus 2 squared. Okay, good. Gabriel, what are we going to do now? Okay, we're going to move that 11 across. Good. Be really, really careful. There's a -11, so what's going to happen? Plus 11. Mr. Beeman, what's going to happen next? Let's do that. X plus 11 over 3. Do you see how a little bit at a time we're getting closer and closer and closer to y being all by itself? Caitlin, what would we do now? Take a square root. I love it. So we're getting closer. Getting closer and closer and closer. And of course, the last little step, the only thing left, minus the 2. And of course, we're going to call this thing g inverse of x, right? G inverse of x should be the square root of all this stuff with a -2 at the end. Let's go back and look. You see the times 3? What do you see over here? What's the opposite of multiplying by 3? Dividing by 3. Do you see the plus 2? What do you have in the problem? Should be a minus 2. You see the minus 11, what does the problem have? A plus 11. Now, on the test, strange that we just passed it back, but I'm already thinking about it, but I am. We're definitely into some stuff that I'm going to test you on. Guys, what should happen if I asked you to do this? What should you get if you did g of g inverse of 6? It better be 6 if you did it right. What is g of g inverse of 4? 4. G of g inverse of the square root of 37. Should be root 37. In other words, g of g inverse of x better be x. And this is what I want to do, because if it's x, that means you haven't shown one example, you have shown all of them, and you proved it. Let's see if we did right. Now, I think it's plausible. I see all the little bits and pieces, but is it possible I did them in the wrong order? I might have messed up. I see all the building blocks, but does order in math matter? Ooh, a lot. So here's G, but I'm going to replace this. That's where X was in the original G, right? I'm going to take that original X, and what's going to go in that hole? Eek, all of that stuff. Now, so for some of you fast guys in here and fast girls in here, please, please, please go slow. What's the first thing that you would notice if somebody said, simplify this? Pretend that your teacher is not that bright. Because when you do a proof, you're supposed to show line by line why it worked. What do you guys see immediately? You see those two 2's? Would that be easy to make go away? I got a -2 and a +2. Is that nice? Oh, okay, that's better. Then I've got what's left inside was x plus 11. Okay, what do you see next? Now, by the way, I'm not doing PEMDAS in reverse. I'm doing PEMDAS. I'm doing it straight. What do you guys see next? Would the square and the square root cancel each other out? Oh, that's pretty good. Now what do you see? I see the 3's go away. What's the answer? Did it work? Oh, so that's not just one example. That's all of the examples. The bummer that I'm saying, this is what I'm saying, go slow, is this is what I see people do all the time. They're like, the 2's cancel, the square root and the square cancel, the 3 and the 3 cancel, the 11 and the answer. Does this read like anything to you? I mean, honestly, I can kind of follow your logic, but it kind of looks like you blew up the page and said a miracle happened X, doesn't it? Because I could do this on any problem in the world and just write X at the end and it looked like I tried something, doesn't it? Please don't do that. See, show me the process that goes down the line. Now, I was going to do this problem with you and I just decided not to. I'm going to show it to you because I have it in my notes, but I want to save time. You see this dude right here? What's the problem with it? The problem with it is right now, as it stands, I don't have a stinking clue where the vertex is to know where to cut it off. Do you? Huh. Well, you did learn something back in Algebra 2, believe it or not. You guys remember doing that? That the vertex happens at -12/6 or -2. So this h of x could be rewritten like this. And then if you took the time to plug -2 back into the original problem, this is a little hard, But if you plug -2 into the original problem, you get 24, you get -12 minus 24 is -12. You get -13. But if you go back to algebra 2 and you figure out your vertex, now do you know where to cut it again? You're going to cut it at -2. So if somebody is mean and they don't give it to you in vertex form, get it in vertex form. But I wanted to make sure I had enough time for this little gem right here, because you're maybe not going to like it so much, but this one's important, okay? Because I will ask you that one on the next test. Number 3. Here's h of x, everybody. Fun times. Here we go. A rational equation. If you haven't caught that, I want to deal with polynomials. I've done that. I want to deal with radicals. Have we done radicals today? We've done it a few times. The last thing I want to be able to deal with is fractions. So many students, by the time they hit math analysis, will religiously skip every stupid fraction problem they've ever seen to where they build it up into this big thing, and trust me, you can handle it. So right now, tell me something about the domain. What do you know? Can't be what? 3/2. Which means when I go find my new stuff, I already know that y can't be what? Oh, that's kind of interesting. By the way, x equals 3/2 means it was a vertical asymptote. That means, what is my new one going to have? What is a vertical line going to become under one of these things? Is a vertical line becomes a horizontal line. That's kind of weird. Huh. So let's swap x and y. And here's where people go, and they look at this and they go, uh-oh, how in the heck am I going to get y by itself? Look at it. Does that look like a mess? I got y on top and bottom, and I need to get it by itself. Easy fix. Here we go. Watch. Call that 1. Cross multiply. Okay, so in that step, what did I achieve? Number 1 that's better. Is I got no fractions anymore, right? Watch the next step. Okay, so what's the first thing I did after I swapped x and y is I cross multiplied for the purpose of getting rid of the fraction. Cool? This is the important step right here. Here we go. This is the money step. 2xy minus 5y equals 3x plus 7. I just did a little bit of a shell game. I just moved the marble around under the cups, or, you know, I played, what is it, 3-card Monte. I moved some things around to see if you could find it. What did I do structurally about the problem is notice every single term that has a y in it is where? On the left. Every term that does not have a y is on the right, because now since they both have a y in common, I could factor out a y. What is the only thing left to do to get y by itself? Divide. You see it? The only thing I have left to do is divide both sides by that, and this is now h inverse. It's going to be 3x plus 7 over 2x minus 5. What do you guys think? Not too bad, is it? Oh, what's the domain? What can x not be? 5/2. Which means this range up here was y can't be. Hey, what's the significance of 5/2, everybody? That was that horizontal asymptote that we talked about in the last unit, isn't it? You see it? So I want you guys to try one on your own. This is number 4. Yours is going to be called j of x. In one way, I made yours nicer. So let's see if you guys can find j inverse. just a couple minutes behind where I want to be to get you guys to the activity that I want you to do. All right, who's got the first step? I want to get you guys, okay, go ahead, Singer. Okay, so you had 4xy plus 5x is equal to y minus 2. I like it. Good. Okay, somebody else, what's the next step I want to do? The big one, yeah, Gabe. Switch the 5x and the y. I love it. Let's bring the y over. By the way, do you have to be careful with your pluses and minuses? Ooh, boy, that'll get you. Okay, why did we want to switch those places to get the y's on the left side? What was the whole reason for that? Because now I could factor out a y. And if I factored out a y, and what's the last then step is that j inverse of x is negative 5x minus 2 over what? 4x minus 1, which means what's my new domain, everybody? What can I not have? 1/4. One thing I love about these problems is they self-check. You see this 1/4? Where did I get it from? I got that 1/4 from the domain of this dude, right? Look right here. Do you see the 1/4 sitting right there? I hope you do. You see your horizontal asymptote at negative 5/4 here? I hope. See the horizontal negative 5/4? Ooh. See, if you don't see all that crisscross logic that's happening, you know you made a mistake. So your homework over tonight is to finish 1/4 and 1/5, no big deal. But in addition to that, we're going to start the next thing right now. So take out your Chromebooks. And I just shared something. I shared it last night, but I gave you a brand new share right now. So open up, it's a student activity builder greeting, and it has a whole bunch of numbers. But what you're going to get is you're going to get to this activity right. I'm going to make this smaller so I could bring it across. You're going to get to this little activity right here, and you're going to start learning something about graphing by transformation. And I think many of you will actually like this activity a lot because it's going to relate to something you did quite a lot last year, but I think it's in a little bit more interactive way. So hopefully this will be useful to you. I'm going to walk around and help you. I want you to try to get to about number 12 today. That's all, about the 12th slide. And I would love it if you interacted with each other and move your desk around and sit next to each other and talk and help each other, okay? Trying to keep the lectures under the hour limit, okay? So anyway, that's what we're gonna do. Let me know, raise your hand if you get stuck.